About proofs about applying the segment addition postulate, the midpoint theorem. So we need to know what all that stuff is. So let's start on this page. So first of all, when you do proofs, you're going to have a statement and a reason column. It's a 2-column proof typically we do. That should look familiar to you. Creates 2 columns. The left side is the statements. And the right side is the reasons. And then you get to number all of your stuff. You always put the given down first. Next, write down the given as your first statement with the reasons as given. So the reason is always given when you write down the given information. Unlike in algebraic proofs, there's going to be multiple givens. So write them all down. You might have to sharpen it, Rob. Unless it is sharpened, then you're lucky. Use the picture as a guide, a roadmap to figure out where you are headed. Label the picture from the given information. Add markings, drawings to your pictures as you include it in your proof. If there is no picture, draw one. You're going to use definitions, postulates, theorems to arrive at the final conclusion. Your final statement should always have a reason, and the reason is not proof. So just quickly, definitions are defined. Those are one thing you've dealt with your whole time. Theorems are proven, so they need to be proven first before you use them. We won't do that in your class, but if it was like an upper level class, they prove those theorems before they can use them. They have been proven by somebody. And postulates are just like assumed to be true. They assume that they're correct, essentially. Okay, so important definitions, postulates, and theorems you are going to be using in your proof. So you might want to have this slide open to know like some of your reasons. So these are reasons that you could use in your proofs. So the transitive property of equality or congruence. Equality is if it's an equal sign, congruence is if it's a congruent sign. So if A equals B and B equals C, then A equals C. That's much like the law of syllogisms. If that middle 2 pieces are the same, so B and B are the same, then the outside 2 pieces equal each other. That's the same as congruence. If A is congruent to B and B is congruent to C, then A is congruent to C. Substitution. If A is the same thing as B and B plus 3 is 4, then A plus 3 is 4. Because A and B are the same, you can replace B and A with each other. So A and B were just replaced with each other because they are the same. So when you think substitution, it might help to think replace. If you can replace it with something that is the same, that is substitution. The symmetric property of equality and congruence, if A equals B, then B equals A. Or if A is congruent to B, then B is congruent to A. Just switching it over the symbol. Whether it be equality or congruence. Midpoint theorem. If B is the midpoint of AC, then AB is equal to BC. So midpoint theorem tells you that the 2 pieces are congruent. So there's a difference between the midpoint theorem and the definition of midpoint. So make sure you guys are looking at this while you're doing your notes. So again, there's a difference between midpoint theorem and definition of midpoint. In definition of midpoint, if the 2 pieces are the same, then the midpoint is that middle piece. So it's telling you if the 2 pieces are the same, then you have a midpoint, and that's the definition of midpoint. So definition of midpoint tells you that a point is a midpoint. What's wrong, Rob? Come sit up here by Casey. Come sit by Casey. This says two pieces are congruent, and this one says that the point is the midpoint. If you need to move up, you can sit next to Casey. Definition of congruent segments is used when switching from congruence to equivalence and equivalence to congruence. So, for example, if I have A is congruent to B, I can switch that to A equals B with the definition of congruence. Or if I have A equals B, I can say A is congruent to B by the definition of congruent segments. The reason you have to do this, why? Well, you have to do it because you cannot add things that are congruent. That's not an equation. That's a congruent sign. So it must be in an equation, so an equation symbol, the two lines, before you can make equations out of it. And with the segment addition postulate, you're making equations. So if you start with congruence, you're going to want to switch it to equivalence. That way you can use things like substitution or the subtraction property of equality or the angle addition postulate. Those are all important things. Again, you may not create equations until it is an equation. So if it starts off by telling you that two segments are congruent, you must switch them to equals by using the definition of congruent segments. Rob?
B plus A?
This is A is congruent to B, and then there's an arrow. It can be turned to A equals B, or A equals B, arrow, A congruent to B. Again, please move up. There's an empty seat. It is small, I know. So subtraction property of equality is when you subtract the same term on both sides. And you can't choose subtraction property unless it's of equality. Do not use it with congruence. And segment addition postulate, the two parts make up the whole when you're adding two pieces together. When I snapped that pencil and I tried to put it back together, that's the segment addition postulate, okay? We're going to be doing proofs with that. When you are ready, we're going to get started with proofs. What's up?
Will you be breaking more pencils?
No, that's not my plan for today, unless I need to. Please put your phones away, guys. This is brand new to you guys. This is different. You need to be paying attention. You need to be using your notes tonight. The homework is going to mimic a lot of these proofs, so you might as well have the notes out while you're doing it so you can see what to do. All right. Given that AB is congruent to CD and CD is congruent to EF, prove that AB equals EF. So I'm going to draw a picture because there's no picture here. So A, B, C, D, E. So we know that AB is congruent to CD. I don't have enough yet. And it's also congruent to EF. So we need to go through a proof to prove that AB is equal to EF. Well, from this picture, is it pretty obvious that they're the same? Is it pretty obvious? Okay, I know that sometimes that's going to get really frustrating, is it's going to be like, well, duh, that's the same thing. I mean, you just drew that picture for me, right? You still have to create a formal proof to prove it. So we start by writing down our given information. So Morgan, what should go in number 1? I'm sorry, I couldn't hear you. Yeah, so AB is congruent to CD. And then CD is congruent to EF. So notice I have the line markings over it when it's congruent. So you have the line marking, the line segment marking when it's congruent. And then when it's equal, you have no line segment marking. So go ahead and get that stuff written down. All right. Why can they say AB is equal to EF or congruent to EF? What property allows us to say AB is congruent to EF? The middle two pieces are the same, right? The middle two pieces are the same. So we can say the end two are congruent. What property is that? Devin?
Symmetric property of equality.
Symmetric flips it over the equal sign. So I understand where you're coming from, but it's the same thing on both sides, yeah. Yeah, it's like the law of syllogisms that we did last week. Law of syllogisms is basically the transitive property. When those middle two pieces are the same, we can connect the end two pieces, so that's the transitive property. In this case, it's of congruence, right? We will just say transitive property. Okay, so definition of congruent segment. Look at what that is on the previous slide and tell me what you think we can write then for that last statement. What does the definition of congruent segments tell us, Carmichael?
That AB equals EF.
It means we can switch from congruence to equals or equals to congruence, right? That's what that means. So that just means we're going to switch from congruence to equals because our proof statement is in A equals. Notice I dropped the line segment when I went to equals. The line segment is only there when it's congruent. Okay. If you want to get technical with this, you can put of congruence with the congruency symbol. If you want to put of equals with the equal sign, that's two. That's fine. If you just put the transitive property, I will also be fine with that. So see if you have any questions for me so far. All of your proofs will be fill in the blank so far, okay? Just so you guys are aware. Which can be good or bad depending on how you think. What questions do you guys have? Because this is brand new. I have seen a lot of you guys flipping back and forth to those properties. That's what you need to do on your notes, okay? Use your notes, use your homework together. They're going to be similar type proofs. All right, so K is between J and L. JK is 3, and JL is 10. So I label my diagram when I have my given information, and we're trying to prove that KL is 7. Well, looking at this, is that pretty obvious to you guys? That's why proofs can be a little bit frustrating, I think, because it is pretty obvious sometimes, but you still have to be able to do it in a proof statement. So Harmony, what would you have to put in line 1? Give me one of your pieces of given information. Yeah, we always start with our given information. So one of them is K is between J and L. So we have 3 pieces of given information. 3 pieces. Gabe, what's another one?
JK equals 3.
Good, so that, yeah, JK equals 3 and JL equals 10. So we know those are our 3 pieces of given information. You always start with your given. If it wasn't even written in here and there were just those blanks, you always start with your given. Granted, you could put them all in one line. That is allowed too. So if you wanted to, you could say J is between, or what is it? K is between J and L. JK equals 3 and JL equals 10 and put it all in one statement. That is also allowed. All right? This is just separating them. It does not matter if you put them all in one or separate them because they have the same reason. Okay, who can tell me why we can put JK plus KL equals JL? Why can we say JK plus KL equals JL? What property is that? Abby?
Segment addition.
Yeah, you're adding the 2 segments together. Do not get confused. Tomorrow we're going to be using the angle addition postulate. So only use segment addition when you're talking about segments. Only use angle addition when you're talking about angles. There's no such thing as a segment subtraction postulate. So don't start saying that. There is just a segment addition postulate, just so you guys are aware. Postulates are assumed to be true. So it's pretty clear that that makes sense, but there's no proof to it. Again, these are segments, so that's why you're using the segment addition postulate. All right, the next one says we're going to be using substitution. What do you think they substituted? What do you think they substituted? What are we thinking here? Katie?
They substituted 3 for JK, 10 for JL.
Yeah, we know that JK is the same thing as 3, so we can replace it, substitution. We know that JL is the same thing as 10, so we can replace it, that's substitution. So that comes from those steps up there. So where does this come from? Some people do this and you don't have to if you don't want to, but this comes from step 2 and 4, and step 3 and 4 work together. Do you see that? That I'm telling you where they come from here? Well, it makes sense because 2 and 4 are working together and 3 and 4 are working together. So that might be a way for you guys to go back and say, why did we do that? This is why we did it, those 2 steps, okay? So now we have to get it. Remember, our final step is KL is equal to 7. What could we do to get to KL equals 7? What could you do to show that KL equals 7? Rob? What property is that if you subtract 3 on both sides? You subtracted 3 on both sides, so it is so it's the subtraction property of equality. Because you can subtract if it's an equal sign. If I put subtraction in POC, that means property of congruence, if you ever see that. All right, look at those first 2 that we've done. See what questions you guys have for me so far. No, there's no such thing as a reason that's the segment subtraction postulate. I'm saying don't use that as a reason. You can subtract using the subtraction property, though. When you're ready, please flip to the next slide. If you are not, please ask a question. If you have a question about where the heck are these postulates and theorems and definitions even coming from, let me know. If you have no clue how we got from step 1 to step 2, let me know. You guys have to be able to do this on your own. All right, then. So it says prove that if AB is congruent to CD, then AC is congruent to BD. So what is our given information in this case? What is our given information in this case? What do you guys think the given is here? What is the given? Logan, what's the given information here if it says prove that if AB is congruent to CD, then AC is congruent to BD?
AB is congruent to CD.
Good, and then what are we trying to prove, Logan?
That AC is congruent to BD.
So the hypothesis is your given. The conclusion is your proof. Okay, so we are given A, B, and CD are congruent. Those are already marked. So what needs to go then in step 1, Emma? What needs to go in step 1? Okay, so what is our given information? To CD. And what's your reason? Given. Okay. What is your reason when you switch from a congruent sign to an equal sign? What is your reason when you switch from a congruent sign to an equal sign, Hayden? Look at the first page. You can either look at the first example, Hayden, or look at the definitions on the first page. Either one will help you there. Okay?
Definition of congruent segment.
Yeah, so just go back to your definitions. I put those on there so I could help you guys out a little bit. I was hoping it would help to have that there. I don't know if it will or not, but it is the definition of congruent segments. To switch it from equals to congruence, or congruence to equals. Okay, let's look ahead a little bit, because sometimes you have to do that when you're doing fill in the blank proofs. But this one has BC plus CD is equal to BD. What would they have used to get BC plus CD is equal to BD? What would they have used in step 4? to get BC plus CD is equal to BD? What postulate, theorem, or definition is that? You're adding two segments, so it is the, which one is it on the front then if you're adding two segments?
Substitution?
Look up for the thing that says something about adding in segments.
Addition, segment addition.
There you go. So step 4 is the segment addition postulate. So they added those two segments already. So what two segments are they going to add together then for step 3? What two segments do you think they're going to add together for step 3 if those two are the one for step 4? What else? What else? What's the other pieces you could add together to make up something? What two pieces can you make up to add? Let's go there. Which ones? What are you thinking, Rob? We don't want to go the whole length. Do you see how BC plus CD is just like that? It chops off AB part. So let's chop off the end part there. So if we chop off CD, what could we add together, guys? A and B and B and C to be AC. So why are you doing that? So that's the confusing part for some of you guys here. So why are we even doing this? What are we trying to prove? We're trying to prove that AC is the same thing as BD, right? Do you guys see that? We're trying to prove that AC is the same thing as BD. By doing this, we have AC and BD in our proof now. Do you guys see that? So the reason we did that is now we have that this and this are in our proof now. So now we can try to go about proving it. So sometimes you have to stop and think about where are you trying to get to. Well, I need to get to AC and BD being the same. So I need them in my proof somewhere. I can't just all of a sudden get them to appear in my proof. And to do that, we use the segment addition postulate, which is something we can actually use. It's not just magic, okay? It's there. So from there, we say that BC is the same thing as BC. I don't know if I wrote this property on there or not. On the front page, I might not have. I did not. Does anybody know what this property is? The same thing equals the same thing? We talked about it a little bit last week with the algebraic proofs. Starts with an R. Yeah. Yeah, it's like looking in a mirror. Reflexive property. So the same thing equals the same thing. So you use that so that you can use it in your proof later on. Okay, so now it says that CD plus BC equals AC. So let's go back up to the one that says equal AC. Was CD originally in the one that says equals AC? Was that originally in there? No. Why? What is different about 3 to 6? What is different about it? What's different about 3 to 6? What did they change? What did they change from 3 to 6? What do you guys notice is different? Which one did they switch, Rob? Carmichael, which one did they switch?
They switched A, B to CD.
Yeah, so this is the same and that's the same, but this is different here. Why can they switch AB to CD? Why is that allowed? Look at the above it. Why is it allowed to say that AB is the same thing as CD? What number in here allows us to do that? What step allows us to do that? Step 2, right? Harmony says step 2 because AB is the same thing as CD. So since AB is the same thing as CD, we can replace it. So using step 2 and step 3, we're able to say CD plus BC is equal to AC using what property if you're replacing? What property is replacement? Carmichael? I know, you guys, this is difficult. I get that. We're going to spend the block day, going over the 2 proofs that we're going to do the next 2 days. So this comes from steps 2 and steps 3. If you want to know where that comes from, it comes from steps 2 and step 3. Just so you guys know, segment addition comes from the diagram. Do you have a question, Austin? Okay. All right. So now we need another substitution. What are they substituting? We're trying to get to AC is congruent to BD. So we know that this last line here needs to say AC is congruent to BD. Why, we don't know yet, but we need to be able to say that. So what needs to be above this? And substitution means two things are the same. And these are the ones with A, C, and B, D in them. What do you notice about 4 and 6? Desiree? They both have equal signs. Okay, that's good. What are they both equal to, Desiree? What do you notice they're both equal to? So these two pieces aren't the same, but what are these sides both equal to? Yeah, if you add those in opposite orders, does it matter? No, 2 plus 5 is 7, and 5 plus 2 is 7, right? It doesn't matter the order you add things in. So if these two sides are the same, if those two sides are the same, what can we say? If these two sides are the same, what can we say? Yeah.
I was gonna say that BD and AC.
AC and BD would be equal. But we can't say congruent from here because there's equal signs still in them. So that is the substitution property there. So because those two pieces are the same, we can say because of 4 and 6, we have substitution going on there. So again, I'm putting those numbers there so you guys know where I got it from when you go back to look at your notes. All right, what allows us to say AC is congruent to BD? What is that? What is the reason we use there? When we switch from equals to congruence. What is the reason when you switch from equals to congruence? And yes, you have to do this step because that's what the proof is in. Morgan, what are you finding? Which one is it? Definition of congruent segments. Welcome to proofs.
This makes 0 sense.
Why doesn't it make sense? I mean, it should be logical. Proofs are logical.
Makes
This makes
sense.
no sense how you go from B equals BC. Why is that even there?
It's because BC is being added, so they needed to say that. Was that necessary? No. You did not need that then.
Why are we
Yes,
trying
it
to
is.
find this?
This
To
makes
prove
no
what the
sense.
using segment addition. I know, but to tell you the truth, guys, proofs are really good for you guys to understand logic of why you're be able to use what you're using. And no, it is. But I know it's difficult and it's going to be weird. Triangle proofs are probably the easier proofs when we get to those. Those are a little bit more logical, but
See, people are just making this up.
no, they aren't.
I need
Proofs are really important for understanding the logic of why you can do stuff in geometry. All right. Shh. So CD is congruent to EF, and then you also know that CD is congruent to FG. So we need to prove that F is the midpoint of EG, of EG. So what do we start off by writing, Cameron?
CD is congruent to EF.
And?
CD is congruent to FG.
Good, those are our given information. So then they say CD is equal to EF and CD is equal to FG. That is to change it to equivalence. So what do we use when we switch from congruence to equivalence, Ian? What do you use when you switch from congruence to equivalence? We've done it a couple times now, so you can look at other proofs or you can look at the front page where the definitions are.
Is it segment?
You're not adding anything. Segment addition postulate means you're adding things. The last proof, the last step we used it.
Last step, definition of.
Yeah, if you switch from equals to congruence or congruence to equals, that's the definition of congruent segments. Greg, was that what you were going to say?
What's the difference between definition of congruent segments and the transit?
So congruent segments means you're switching from congruence to an equal sign. So the transitive property has to all be equals or all be congruence to start with, and the transitive property is like the law of syllogisms. So if it has the same two middle pieces, you can connect the two pieces together. But you can, so substitution, I believe, is only used for equivalence, whereas transitive property can be used for either one. So that's why sometimes you have to switch it to equivalence so you can use other properties. All right, so why can we say that EF is the same thing as FG? Why can you say EF is the same thing as FG? I'd accept two reasons here. Why can you say EF is the same thing as FG? What are they both equal to? What are they both equal to? So if they're both equal to CD, then they're both equal to each other by what property? You could use transitive because they both have that middle piece, or what is the other one you could use? Yeah. Symmetric just means the same thing as flipped. Substitution is a replacement. So you can use transitive or substitution. I really don't care which one you use. And they are just using step 3 here to show that. Okay, then it says definition of congruent segments. So what does that mean you're going to be doing there? Devin, what does that mean we're going to be doing there then?
You're going to be putting EF equals FG and making it EF is congruent to FG.
And when you go to congruence, it needs to have the little segment hat on top of it. And what are we trying to prove? Our last line needs to be our proof statement. What are we trying to prove? F is the midpoint of EG. So go to the front page. There is 2 midpoint things. Go to the front page. Is it definition or is it theorem? So definition says that the point is the midpoint. Theorem says that the 2 pieces are congruent. Are we saying the point is the midpoint or the 2 pieces are congruent? The point is the midpoint, so that one is the definition of midpoint. So make sure you're using your notes. All right, what questions do you have? Let's get through another one. And then I'll get you guys your homework. The more examples you have, the better for you for your homework tonight. Go to the very last one. We're going to go to the very last one. Okay, so do you guys notice in the very last one they put all of the given information in one step? That is also allowed. So that is just given. Okay, they use definition of congruent segments, which means they are changing from congruence to equals or equals to congruent. So Daniel, what are they changing then? If you're going, you have to go from previous steps. So what is the only thing they would have changed there? What?
Oh, the equal sign.
Yeah, they would make that an equal sign. So PR equals ln. So we know PR equals ln. And we know Q is the midpoint. And L and M is the midpoint. And we're going to try to prove that PQ and LM are the same. Why can they say PQ is equal to QR and LM is equal to MN? Why is that allowed? Use your own words first. Why is that allowed to say those two things are equal? Why can we say PQ is equal to QR and LM is equal to MN? Yeah. Why is that allowed? Not because they look the same. That's an assumption. What is it in the given information that's allowing us to say that? Said it. Yeah, midpoint means right in the middle, right? So if you look on that front page, is that the midpoint theorem or the definition of midpoint when you say the 2 segments are the same? Is that that's theorem. So theorem is when the 2 midpoint, like the 2 segments are equal. When you're saying that M is the midpoint, that's definition. So this is midpoint theorem. We're using midpoint theorem because of step 1. Step 1 is saying that those are the midpoint. What did they use here to get PQ plus QR equals PR? And LM plus MN equals LN. Yeah. They're adding the 2 segments together to equal the whole, so that's segment addition. And that's just from the diagram. Okay, so now they're using the substitution property. So we're trying to get that PQ and LM are the same. So we need to get to that point there. So we're trying to get to PQ is the same thing as LM. All right. Well, don't we know that LM and LN and PR are the same? Don't we know that these two pieces are the same? I know, class is almost over. I'm aware. So if two things are the same, we can set them equal to each other. That's substitution. So we're saying PQ plus QR is equal to LM plus MN. Because PR and LN are the same. So we just used 2 and 4. Well, QR and PQ are the same, so I can say PQ plus PQ. And LM and MN are the same, so I can say LM plus LM are the same. I just use substitution here. So I'm using 3 and 5 here. And then I just added them together, which is still substitution because you're simplifying the same side. And if you divide by 2 on both sides, you get PQ equals LM by the division property. Okay, do not leave until you get your homework.